Okay students, now today we are going to see the structure of fructose molecule. Fructose structure of fructose. Today we are going to see the structure of fructose. We have already seen the structure of glucose. Now today we are going to see the structure of fructose. In the structure of fructose, first we are going to see the open chain structure. Open chain structure of fructose. Fructose, students, you know the formula of fructose is similar to the glucose, C6H12O6. Open chain structure of fructose, C6H12O6. Now students, how we are going to write down this? We are going to write the structure of fructose. First carbon is CH2OH. It contains CH2OH. This is the first carbon, and last 6 carbon is also having what? CH2OH. Now at the second carbon, students, there will be ketone group, and third carbon you will find hydroxyl group on the left hand side and hydrogen will be on right hand side. In fourth, the hydrogen will be on left hand side and hydroxyl will be on the right hand side. When you come to the fifth carbon, here also hydrogen will be on left hand side and hydroxyl group will be on the right hand side. This fifth carbon will show whether this fructose is D-glucose or this carbon where the OH is present on right hand side. So therefore it is called as what? D-fructose. This fructose we call as what? D-fructose. So this carbon will to which OH hydroxyl group is attached to the fifth carbon. So this is OH is on right hand side. This OH will decide whether the fructose is L type fructose or D type fructose. Now it is a D fructose. Now students, total how many hydroxyl groups are there? 1, 2, 3, 4, 5. So it is also called as pentahydroxy. Pentahydroxy. And it is containing, this fructose is containing ketone. It is called as pentahydroxy ketone. Only one keto group is there. So this is D-fructose. We also call as what? Pentahydroxy ketone. Now students, we are going to see the structure in Fischer projection formula and Haworth projection formula. Now first we will see the Fischer projection formula of cyclic fructose. In Fischer projection formula. Fischer projection formula of fructose. Now students, you know D-fructose, how you are going to convert D-fructose into alpha D fructofuranose, because in this Fischer projection there is a furan ring is forming. That is why this type of fructose is called as what? Fructofuranose. Alpha D fructofuranose. First we are going to make the D-fructose. D-fructose, students, how you are going to make? The first carbon will be CH2OH. First carbon, 6th carbon is also containing CH2OH. Second carbon will have ketone group, second carbon. Third carbon, fourth carbon, and this is fifth carbon. OH will be on this side, H will be on this. H, OH, H, OH. This is D fructose. This is the D fructose. Now what happens, students, in how you, because it is a cyclic fructose. Now fructose will in the cyclic form. Cyclic. So first we write D fructose. How you are going to convert into cyclic. So what happens, students, this OH, fifth carbon OH will react with the ketone group and it will form the hemiacetal. Now this D fructose will convert it into alpha D fructofuranose. What happens, students, when this OH react with the ketone group, it will form hemiacetal. So this is the second carbon. When it will form the hemiacetal, what happens, this CH2OH, which is the first carbon, will come to the left hand side and OH will go to the right hand side. Now other carbon will be as it is, CH2OH. First carbon, second carbon, third carbon will be as it is, fourth carbon and fifth carbon. Fifth carbon OH, it is reacting with the ketone and it is forming the hemiacetal like this. This is the hemiacetal. Understood? Now this OH will be, third carbon OH will be always on left hand side, fourth carbon, fifth carbon. So this is the cyclic structure of fructose. This is called as alpha D fructofuranose because it is forming the furan ring. So it is called as alpha D fructofuranose. Now students, we are going to convert D fructose into beta D fructofuranose. What happens in beta D fructofuranose? In beta D, now we are converting D fructose into beta D fructofuranose. Now students, first write down the structure of D fructose. So D fructose, we are writing how first carbon is containing CH2OH. Sixth carbon is also containing CH2OH. This is sixth carbon. Second carbon will contain keto group. Second carbon, third carbon, fourth carbon, and this is the fifth carbon. Third carbon is OH on always on left hand side, and H will be on right hand side. H, fourth carbon, H is on left hand side and OH will be on right hand side. And this is the simple D fructose. This is called as D fructose. Open chain structure of D. How it is converting into beta D fructofuranose? What happens, students? Again, this OH of the fifth carbon will react with the ketone. Now in this, what is happening, students? OH will be coming on the left hand side. Second carbon, now OH will come on the left hand side and first carbon CH2 will be on right hand side and other carbon will be as it is. This is the sixth carbon, CH2 will be as it is. Third carbon, fourth carbon and fifth carbon. This fifth carbon is reacting and forming the hemiacetal. It is anomeric carbon because it is containing so many different groups. This second carbon is now, it is an anomeric carbon because it is containing different functional group. Now this is the OH will be, and third carbon will be always on left hand side, H will be in right hand side, H, OH, H. This is called as beta because OH is on left hand side. It is called as beta D fructofuranose. This is in Fischer projection formula. In Fischer projection formula. So students, sometimes in examination they are asking convert D fructose into beta D fructose. This way we have to convert. This is the simple chain structure. We have converted into cyclic fructose. Now students, in next video we are going to see the Fischer projection formula, how we are going to convert into the Haworth projection formula. Conversion from Fischer projection formula to Haworth projection formula. First one is how you convert alpha D fructofuranose into the Haworth projection formula, students. So first you should know the structure of in Fischer projection formula. So second carbon, now here students, in second carbon what happens? OH will be always on right hand side. That is why it is called as alpha. This anomeric, this is alpha D fructofuranose. First carbon CH2OH and 6 carbon will be CH2OH. Now what happens to third carbon? OH will be always on this side, H on this side, H, OH. Fifth carbon, this is third, fourth and fifth carbon. Now it is forming the hemiacetal like this. This is alpha D fructofuranose in Fischer projection formula. In Fischer projection, if you know the Fischer projection formula, then only it is very easy to convert into the Haworth projection formula. So students, because it containing total how many carbon? 4 carbon and 1 heteroatoms. That is why it is called as furan ring. It is forming the furan ring. The oxygen will be like this, and here this is the way you are forming the furan ring. Because carbon is tetrahedral structure, this is the second number carbon. Third number carbon will be like this. Fourth carbon will be here. Fifth carbon will be here, and sixth carbon will be here. This is CH2OH. Now because students it is a what? Alpha. So OH will be always as below this, and this is your CH2OH. First carbons. OH will be on this side. Whatever is there, your on left hand side will be go to the up. H and H, OH. H will be this side. This is called as, this is converted. This way you have to convert it into the Haworth projection formula. Haworth projection formula. Now second students, now we are going to see the how we have convert beta D fructofuranose into the Haworth projection formula. We are going to convert beta D fructofuranose. If you want to convert into fructofuranose, you have to first write down the beta D fructofuranose Fischer projection formula. Second carbon. Now second carbon students, on left hand side there will be OH and right hand side will be CH2OH. First carbon. 6 carbon will be as it is CH2OH. This is your third carbon, fourth carbon, fifth carbon. Fifth carbon is forming the hemiacetal. This second carbon will be act as an anomeric carbon where different groups are present here. Now this is the structure of beta D fructofuranose in Fischer projection formula. If you are able to draw the Fischer projection formula, then only you can convert into the Haworth projection formula. This is a simple way you have to convert into beta D fructofuranose in the Fischer projection formula. How will you convert it students? Because it is hemiacetal, oxygen you have to draw like this. First to make the furan ring, this is the furan ring where 4 carbons are there. This is corners shows you the carbons, 4 carbons. Because it is carbon is always tetrahedral structure, so you have to make the bonding like this. This is the second carbon. In second carbon, students, OH will be on upside. That is why it is called as beta D fructofuranose. OH will be on upper side. First carbon CH2 will be below side. Now OH on this side, H, OH. Now this is the as it is CH2 OH and H. This is the conversion of beta D fructofuranose in Haworth projection formula. This is the Haworth. Now it is in Haworth projection formula. This way we have converted all the alpha and beta D fructofuranose in the corresponding Haworth projection formula. Thank you students very much.